All right, welcome to this live stream for data preparation and workflow management. It's good to see many of you. If you have not done so, I have a YouTube channel where I post recordings. It's available here, and I'll put it to the chat. I have updated the channel already this morning with some stuff for online data online data collection management. Just make sure to subscribe to get a message when videos are up there, especially if you can't make it to the live stream. In case you're not part of online data collection and management, I posted a link on the Canvas page for an internal student WhatsApp group. Join that group if you want to get in touch with others to, facilitate group formation. For example, I'm available on WhatsApp to chat, and actually there are not many people writing to me, so I feel kind of lonely. So if you've got stuff and you get things stuck, I'm here to help, more at the beginning of the course than at the end of the course. I'll try to get you more independent on the way, but don't feel bad if you need support. You're just starting out. Actually, it's stupid not to ask for help. So, well, not stupid, but I don't know. My daughter, she never asks me for help, and she actually wants to try it all by herself. So, it's a natural thing maybe not to ask for help, but I'm here, I'm willing to listen, and it's part of my job, by the way. So, make use of it if you like. I hope the installation of R has worked out. So if you have any problems, put it in the chat right now so you can spend a bit of time about installing R. Otherwise, I will continue. Just put problems in the chat or say, hey, you need support, and I can give you that support. So what you can do right now, I think, is start up R in RStudio, actually. I'll quickly walk through what I want to do today. So let's go to modules and getting started. And the planning here is to walk you through this week's tutorial, which is the R bootcamp, and it gives you a little preview of what to expect. And actually, it refers you to an external website who have done an amazing tutorial that I want to walk through. But that tutorial, as you may have seen, is not very marketing-ish. So today, I'll give you another data set, and like in this stream, I'll just walk you through all of those steps. Well, maybe I skip a few, maybe I pay a little bit more attention to others, and I add my own flavor to this tutorial. I haven't practiced this tutorial, so chances you'll see me, hitting a wall and then trying to, get out again and getting organized and trying to debug. That's the natural process of learning R anyways. Good. So I want to know what's your experience in R. And I actually want to know what you know, in the sense that I think my colleague Arjen van Lin, he's teaching Introduction to Research Methods and Marketing, something like that. So I think he's using R this year, and, give me some thoughts about how far you are. What has Arjen shown to you? You're all taking that class, right? Yeah. All right. So tell me, what have you done? What have you covered so far? It'll help me. You need to unmute yourself if you want to talk, or use the chat. But please don't just consume. Some plotting. Okay, cool. With ggplot, Lorenzo? Also, that's good. Yeah, there are like basic plotting functions. Okay, cool. So, all right. Oh, that's cool. So you did merging. And did you use dplyr with this, or tidyverse, or did you use the base R function? I don't know whether that makes sense to you, but Quentin, dplyr. Okay, good. So do you need this tutorial today? I'm not sure. You seem onboarded. Julie, okay, good. So are you okay, good. It's good to do the best things in life twice or something like that, or at least multiple times. So, this is my flavor of an introduction to R, and then you can, pick whatever you like and think is best. See, part of this tutorial, and I'll put it to the chat so you can do it. And I think the best, whoops, my clipboard doesn't work. So maybe if no, it does. what I was gonna say is, I think it makes most sense trying to get the screen arranged like I do. So you'll open the browser in one window, and you'll open R, and not a window or screen, whatever, and you'll open RStudio on the other side of the screen to be able to tag along. I may decide to do something different on the way. Actually, I'll do it. I don't have that much space on the screen, and I want you to. Yeah, I don't know. Maybe you can have it, well, arrange it the way you want it. But I want it next to each other. But then actually, well, you don't need to see this because this is where your faces show up, and I'll have to crop. But that's not the problem, I think. So we do it like this. All right, and then I'll switch back and forth. All right, so why is it that we want to learn R? So if you followed this tutorial, by the way, did you complete this tutorial already? Or is it like you waiting for me to like do the stuff? Who has completed it? Completed, good, tried it. Where did you get stuck, Wouter? All right, I think it's going to be fun though, even for the people who did it. Yeah, I'm not even good in ggplot. So, I mean, we'll learn new things together. All right, so why do you do R? Well, first of all, everybody is using R or Python in a firm that does something with data analytics. R is a software that I think was first called S in the 80s, or it even started to exist in the 70s. So it's very, very, very old, but somewhat it started to revive in the early 2000s. And I think this is partly driven by the adoption of this language by big software firms like Google, who would prototype many of their algorithms in R before they put them into production. So, more and more people started trusting R as like, a good thing to do. And then in Europe, well, maybe because of funding problems, many university scholars, discovered R as a cheaper alternative to using commercially available software like SPSS, like Stata, like SAS, SAS. These are very expensive packages. And, the moment you try to do something at scale, bigger computers, more memory and stuff, they charge heavily. And big firms are willing to pay for this, but there was a decreased willingness for researchers to pay for it. So more and more people started to adopting R. And today, R is used by literally any researcher, I would say, and it is widely adopted in business. So something that you'll notice is that R looks kind of friendly, at least friendlier than opening R in the command prompt, which you can do too because you install it. If you just type R in the command prompt, R shows up too, right? You can do the 1+1 thing, or you can do it here. So what's the difference between starting up R and starting up RStudio? Well, exactly like this is how R looked when it, was first on the market in the 80s. Command line interface, no graphical user interface whatsoever. And eventually, and it hasn't been for very long, actually, just about maybe five to 7 years, I'd guess, this company, RStudio, started to pick up and build upon the R platform. So they figured they can make a whole lot of money by selling a nice looking graphical user interface that looks like a proper stats program rather than, a geeky looking toolbox in your terminal window. So they started doing this. And the nice thing is about it is many more people started using R because of this, because it looks more friendlier at least than this. And also they heavily invested into the R ecosystem. Many of the packages that are standard today are developed actually by the guys at RStudio. We can only have apps in R because of RStudio's development there. By the way, they earn a lot of money because they allow you to launch their apps on their servers, right? It's free to develop apps. It's also free to run your own server, but we're not so good to set up our own server, so we use their cloud services and pay, right? That's their business model. They use something free, they pump a lot of money in to make it really good, but then they charge extra for other things, which is fine, right? I mean, let them make a business out of it. But so it has become extremely good. Tidyverse, ggplot, Shiny apps, R Markdown. These are all things invented and financed and made available publicly, open source. Everybody can view the code. Everybody can extend it by the people at RStudio. So there's no reason anymore to not use R. In the early days, it was like, yeah, but SUS is more stable and it scales better. And no, I mean, there's literally no reason anymore why not to use it for stats. It has and still has a coding interface. It doesn't have a graphical, let's say, way to say, hey, I want to run a regression. And that's actually a plus. So for example, if you click on new up here and open an R script, you can write some code. And I again use the comment character to explain what I'm doing, and then I'll show some code. I select everything by pressing Command A or Control A on Windows, and pressing Command Enter, and I think Control R or Control Enter on Windows to run my code. So I navigate many things with my keyboard. Right, so Control A, select all, Command Enter to run that piece of code. It has an interface. It may look like a weakness to you if you're used to SPSS, like a stats program that's built on like making at least 1,000 clicks an hour. But this is great because you can rerun stuff over and over again. You can swap data sets and run the same code. It will smoothly process everything. So it takes a lot of time to learn how to code. But after all, you've signed up for marketing analytics, so that's kind of that is something you could have foreseen probably. So yeah, it's good, and it'll once you get the gist of it, it'll make you super productive. So I'm reading a very good comment in the chat to ask for a cheat sheet for R. Well, if you go to our site, and didn't I have cheat sheets examples? Where are my cheat sheets? I thought I had cheat sheets, building blocks, cheat sheets. There you go. So we got a couple of cheat sheets, and I'll put the link in the chat. By the way, you'll learn how to edit this page. So if you find a better cheat sheet, Vasilis, please just add it to the site. So actually, that's a preview for next week, right? But you can just go to GitHub and just enter your own cheat sheet. I'll post the link in the chat for this particular page, and then you could just fiddle around docs. Where is it? Example? No, not this. Building blocks, cheat sheets. There you go. It's an index. I'll just post the link to the file, and you've never maybe seen Markdown, but it's so super straightforward to edit. So just do it and experiment with it. You'll have to learn it anyways. So here we go. And R has a great community, to use. So I was about to give you the tour on how to get started. So how I get started when I work on new projects is that I create a new directory. So on my computer, I would go to research projects, and I would just create, dPrep session 2. Actually, I already have this folder because today's session was ODCM. It was not mislabeled the folder. So dPrep session 2. All right, I can enter this folder. Many people prefer staying inside RStudio all the time because somewhat it's like convenient to not like having to switch, and that's good because it works, right? So you got a file explorer down here where you can navigate to your directories. And I think, what was the name again that I gave? ODC, dPrep session 2, right? You can navigate to that same folder. And you can create new folders by clicking on new folder and all that kind of stuff. So no reason really to leave the environment. A project typically consists of source code and data. And typically we also separately storing data and source code. And there are multiple flavors of it. I think in this tutorial, people are, I mean, the tutorial inventors, they have a data directory and then documents, figures, scripts. You know, I mean, it's essentially up to you how you want to name this. I have my own conventions, so I use source for source code, and I use data for data. What RStudio added to, let's say, maintaining projects is that you can alternatively also create a new project. So for example, you could you know, now choose this existing directory or start it up in a new directory. I mean, let's just start it up in a new directory, call it new project, and I'll select my research folder as the main folder, and the directory name is dPrep session 2 version 2, and I'll just create that project, you know, and then I'm starting off from a template. What you see right now is, well, I would have to recreate the data directory and the source directory here. What you see is a little project file. Well, R kind of now remembers all the setups and settings that you're going to go through when you work on this. So for example, if you're switching projects, right now I'm saving my project. Let me see, there's nothing in there right now, but you know, when I switch projects, it's easier to enter this project. I personally don't use this project files in most of my work, but it may be handy to you. As a preview, my colleague Lachlan Deer, who is going to be teaching you guys next block, he has written own templates, for example, to work on your thesis. And it's called Thesis Project using Tie Some Down, which is like a very nice looking template to write your thesis in R, because that's also what you can do. I'll post the link to his work in the chats. Oops, where is it? Lachlan. So you can explore a little bit of what to do. And, you know, maybe some of you guys are already more experienced in the study and want to start working with this a bit. I'll have to look it up. Where is it? Zip, thesis down, where is it? Lachlan, there you go. I'll put the link in the chat. So you get a nice sleeky looking template. But I'm in this project. Why are you working in a project test rather than working in dPrep session 2? I'm not in test anymore, right? Oh, okay, good. Anyways, let me continue. So I'll bring back the screen. So we walked through the directory setup. Yeah, something that may be weird to you guys is the working directories. So let me create some fake data. Okay, I'll just create some data. I'll open a new text file, and I call this, you know, I just do like 1, 2, 3 in here, and I'll save it in data.csv. Okay, and I'm in the source code, and I'm creating a source code file, R script, and I'm trying to load this data set. And I do this read table, and the name of this is data.csv, right? And I'm saving my source code file in the source code folder. I call it load to data. All right, so I'm trying to run this now, and R gives the message that, well, can't do it because I don't find the file. This is the most typical problem for everybody that starts us using R. This is because we're working in a folder, and R right now is maybe thinking it is currently in a different folder. So when you do this command, get working directory, get WD, get working directory, and I'm zooming in as we speak. So you can see what I'm doing. Well, that is definitely too much. Get working directory. So R currently is in this folder. Okay. So if you want to access stuff in the data folder, you have to enter that data folder first. And we do this by writing data / in front of it, right? Because we're in dPrep session version 2, that's the main directory. This is this one. We want to go to data CSV, right? If we run this now, the data is loaded, right? And there are multiple ways in which like working directories are handled. Some people prefer to always make the working directory the project directory. So you would go to data. You would have to pre-append data. Let me write. If project directory is your main directory. But others, and I'm one of them, I prefer making all of the file paths relative to where your current file that you're working in is. So load data, that's the source code that I'm writing, right? To get my data, I will first have to go ... up and then go into data and fetch it. That's my way. So in many of the stuff in my work, what you see is that when I work in a script, I would first go and set the working directory to this source file, to the source file directory of load data. I do this manually. And then all of my file paths are relative to where my current file is located. And as I'm explaining this to you, I figure you have a strong preference for not doing it the way I do it, because the other thing just seems so more simple. And I'm just realizing this as I'm speaking, right? This is a convention that's somewhat I got used to, but it involves this thing of like setting the working directory, which is maybe something weird. So anyways, you'll see a mix of flavors here in this course. You're going to get frustrated at times because you don't know why your code works or doesn't work. Probably it has to do with like the relative file paths that we're using here. So for now, because I've created a project, and in a project in R, everything is defined relative to the highest directory in your project, to the main directory. Let us just go with this convention and set it back to the project directory. So now a working directory again is what it was before, and we can load the data. That's a lot of talking for a little thing like directories, but it is a very important concept. Well, and finally, I showed to you how to interact with R, such as you write source code and you can select it either with your mouse or just like Control-A and run it. If you want to run your entire source code, you can also use those buttons by clicking on run. Or if you're tired of actually seeing what happens on your screen, you can click on source, and it'll run in the background and you don't get any output. Now I'm creating a little code that takes a long time to run, all right? For I in 1 through 1 million, print I. Let me just prototype this for from 1 to 10, right? It's going to print it. If I do this up to like 1 million, well, let me do like maybe to 10,000. This is going to take, well, it doesn't take a long time. So let me do it to 100,000. This takes some time. Okay. In R, you will have to deal with like waiting for stuff many times. Such as, by the way, Renus, you can hear me well. I think the others can hear me well. At least I would be surprised. So it's you. So maybe you, I don't know, change your settings a bit or something like this. I haven't changed my setup. Maybe unless my laptop is, giving problems, but I don't know. So if anybody else has problems, please signal so I can change stuff, but I don't think it's me. Thank you, Esther. Success. So this takes a long time. I'm saying like, you use R maybe to process data, which will take a lot of time. So R has this amazing thing of sourcing a file as a local job. Okay. And what happens is that this will run in the background. Just click like Oh, yep. Okay, this one didn't work, so let me see. I didn't test this before. Sources local job. Oh, working directory is not the source code. It is that's the other thing. Okay, so the working directory should be the project directory. And if I now start it up, the job is running here while you can still work in R and further develop your code, right? So I have relegated part of what R should do to like this external job function. And interestingly, because there's so much printing going on, it pretty much screws up R. Just remember, I'm trying to close this job right now. Maybe that's another good lesson. R crashes at times. And sometimes you're executing a command that you can't stop. I got a really good trick for this, which on a Mac, it's called Option, Command, and Escape. And on Windows, it's Control, Alt, and Delete. And trust me, I mean, I didn't plan on this, but this is actually a good thing. Sometimes I just have to first quit R and restart R, which I am doing right now. And the good thing is I saved all my stuff, just double click on my project and I'm back in live. You know, sometimes also you're loading data and the data set is too big and you can't abort this. And all you need to take away is there are different ways of executing your stuff. All right. Good. Any questions so far about the R interface? All right, good. So I'm continuing now. And my idea now is to give you a little introduction, you know, more related stuff in R, like basic R stuff, without much data, I believe. We're creating data on our own. And then after the break, we're actually loading in real data. All right, that's a bit what I want. We got data types in R. By the way, can anybody put in the chat who wasn't here this morning? Because I need to know for how many people I need to, how many people haven't heard the Python introduction this morning. Otherwise, I can relate what you learn now with what you learned in the morning. All right. So I'll just assume you've been there or you have some affiliation with data. So just like Python knows data types, like strings, also R does this, right? So for instance, we have names and my name is Hannes, and we have numbers, which can be, you know, some number. I select it and I copy it to the console. Maybe an important comment about using the script versus using the console is that, you know, when you try out stuff, I use the console. I'm just like, okay, names equals Hannes, and then can I do names plus one? No, because Hannes is a string and one is a number, right? But can I do numbers plus one? Yes, it's 564. So, you know, I'm prototyping stuff. But whenever I want to add stuff to my program, I'll put it up here. You know, the good thing is that you can very nicely edit this stuff. You know, even if you do a mistake, such as doing like this, and you run it, and you see, oh, it doesn't work. You know, you can very quickly correct it here. So, you know, the difference between using a typewriter, which is like below in the screen, and a word processor called Microsoft Word, you know, where you can actually edit text. That's kind of where that difference comes from. We get strings, we get numbers, and we can also have vectors of numbers or strings. So for example, I could have a collection of numbers, right? And then numbers is going to be a vector, like a collection of these numbers. There are different ways to create such vectors. For instance, this creates a number sequence from 1 to 10. You know, in Python, it's way more complicated to do this. So this is like pretty fast. Then you can write functions with, well, let me actually see what other stuff is in here. Creating objects, we got that, objects versus variables. What I'm creating are variables in essence. Yeah, I can just proceed. You already saw me commenting upon my work. There's something important to say about comments. So actually, I think on Tilburg Science Hub, I hope at least, Tilburg Science Hub, principles of good coding. Yeah, I'll just copy this to the chat. I hope that we get some comments here on how to write good comments. So usually you don't write comments that repeat anything that's also written in code. So for example, if I was going to give a comment here, that's a stupid comment because the comment will quickly be outdated. Suppose you're later going to run your program from 5 to 10. The numbers are going to say 5 to 10 while your comment still says from 1 to 10. So you want to add comments to your code that complement the code, but not like copy the code in human words. So what I would say here, define range of numbers, for example, like this, right? So this is very clear, right? And like this, you're going to learn different ways of like phrasing comments. And like if you look at my earlier projects of the source codes that I have written, my comments are not good, but I'm trying to pass on some knowledge here. So we got writing comments. R also knows functions, just like Python does as a proper language. So for instance, we can write a function which takes the square root of numbers. So for example, well, actually, that doesn't make so much sense. Let me see. We take a function and we give it a name. Well, let's do something different. We'll make a function that adds 2 to a number. Let me just say plus 2 is a function of with argument x, and it should do x plus 2. So the good thing about this function is that we can now call it. I'll call this function in prototype mode and give it 1 argument. That's 3. Function works, but I can also pass it multiple numbers, 1, 2, and 10, and it'll do the calculations. With writing code, that is a very useful thing to do. Sometimes your functions, they run over multiple lines. If you do that, you use a squarely bracket to open the function and a squarely bracket to close it. Here's something about that function. So for instance, right now here, I do something like print, I'm done calculating. Suppose this is an action which takes a lot of time. I'm calling it. And one nice way to call the previous command that you've done is just go here with your cursor and press the upper key. And you can go through all of the comments you've recently written. Like this, we kind of have a better typewriter than the original one, right? So we can go back to this line and see what happens when I re-execute this. Okay. Plus 2. Well, the problem is now this function didn't tell us the result of the operations of plus 2, right? The previous function which I called, let me call this 2b and this is 2a. If I call this function with 2a, I get the results. When I call 2b, I think it's not loaded in memory, so I first have to source this, Control Enter. It just says I'm done calculating. This has to do with the fact that a function always returns the last line of its code. So right now it's just returning I'm done calculating. It doesn't return this. To change this behavior, we can explicitly tell this function what to return. Return to us as a user x plus 2. And when I now call 2b, I again get that result. Right. There's a question about it. So these are basically like lists in Python. Yeah, the 1 to 10s, that's a list. Well, R knows also lists. Like with lists, you can't readily calculate. I think that is the thing. So if you're creating a list in R, that's this. Okay. But you can't, let me call this my list, but you can't do my list times 2, right? Because a list can contain anything. A list could also contain names, and it could contain plots. It could contain anything. It's a list of everything. That, look at this, my list. This is a string, this is again number. So a list by construction is nothing you can mathematically calculate with. Whereas a vector is a mathematical concept that you can use for, calculating. 1, 2, 3, 4 is a vector, into 4 is, that result. That is maybe the thing here. In data preparation and workflow management, you use Python to do scripting. We don't use it to do any calculations except, I don't know, doing +1 to get the next page on a scraper. But R here in this class, we use for calculating wrangling with data and these kind of things. That's why you learn different concepts here. You're saying, you read in the tutorial that you're not supposed to use equal, but instead use, is that true? For true R evangelists, probably it is. I don't observe any difference unless you can tell me one. So it doesn't matter. It matters, it matters for some stuff, but nothing that you should worry at this moment in time. Good, so you can use it interchangeably. Good, let me see what else I got on this. Vectors. Okay, there are 2 more concepts before I go on the break, which is subsetting and missing data. So let's create a vector. Let's call this my vector. And it goes from 1 to 6. Suppose I want to call an element, for example, the first element. In Python, you always choose the 0 element as the first one. But R doesn't know 0. It says, nah, nothing, empty, nothing. So R starts counting with 1. Actually, that's a good question to ask to Google. Why does R count from 1, whereas Python starts with 0? I don't know the answer. There you go. Well, apparently Mr. Freeman has a response on this. But there seems to be a scientific response to this, which I don't care so much about. So at least we just have to take it as taken. So we got our vector, and we can subset it by calling, the first element, or by calling the first 3 elements, or by removing the first 3. By removing the first 3 elements. I got an error because it doesn't know whether the minus belongs to the 1 or to the entire thing. So if I actually wrap this in brackets like this with a C for creating a vector, it removes the first 3 elements. An alternative way to find stuff in your elements is saying which elements you want to see and which not. So suppose I say, I want to see this one true, I want to see this one true, I don't want to see this one, and I want to see the last 3 ones. We'll index it with true, with a Boolean vector, with a vector of yeses and nos. And final thing I can say is that numbers, they don't really have to know numbers all the time. Data can also be missing, and it's signified by an NA, or it can be plus infinity or minus infinity. If we do some math with this, for instance, multiply this whole vector by 2, we get 2, 4, 10 for the first 3 numbers. If you have nothing and you multiply it by 2, you still have nothing. And if you multiply infinity by 2, it's still infinity. I tried to explain this concept to my 6-year-old. It was a lot of fun. But once you reach infinity, you can stop counting because you can't add anything. Anyways, we had a fun conversation about that. Also, she asked me when do we reach infinity when we're counting, and the answer obviously is you never reach infinity because you can count it. Anyways, it's break time. I think And I'd like to be on a break for 10 minutes. So what you can do if you're like super, super, super excited to already do some stuff, I'll post a little code snippet and you can post that, paste that code snippet into R. It's namely about loading in some data. Here's the code. And I'll also link to my gist so you can load that. And I'll see you after the break. We'll be back at 1:40, so that's 12 minutes of break. And I'm sticking around for a couple of minutes for questions right now. So thanks a bunch so far. And I'm pausing the recording right now. We are about to start wrangling with real data. And there is a couple of things that I discussed during the break, and maybe you weren't around. So I just want to give the brief summary of this. So first of all, some students have been trying to install packages, for example, the here package, which eases finding directories. So if you want to install packages, for instance, the here package, and you run the command like this, it says here is not found. That reason is that R expects you to enter packages. Oh, damn, thanks for telling me you can't see my screen. I will actually have to start over again because otherwise the editing takes me like a long time. All right, so welcome back to the second part of today's session. Just want to quickly make a remark that when installing packages, you have to wrap package names in quotation marks like this, right? So when you run it without quotation marks, for example, to load the here package, it will throw an error, but you'll have to quote it. And then the other thing that I wanted to comment upon is that in loading the data, and I start a new file, and I'm saving this as, actually, this is actually loading data. So actually, you'll see me in production mode. Sometimes it happens when working empirically that, you write a script and you put different stuff in the script than you intended to. So, we just have to change the name rather than having a load data to, which doesn't mean anything to anybody looking at this project, right? This is just getting to know R. Ultimately, we can even delete this file. Oh, now it's called r.r. I don't want that. What is this? Getting know R. So, and load data, we're going to rename as load data. And I have pasted the URL. All right. So when you run this, it takes a little while on my computer. But what happens to some of you guys is that because this is a 125 megabyte data set, I can look at the data right now, your computer may not be suited to work with this data. In fact, if you write GC, open bracket, close bracket, it stands for garbage collection. For whatever reason, it's cleaning up your memory, actually, that's why. You see how much memory R is using. So right now, to load a 150 megabyte data set, I'm using about 300 megabyte of memory. It's loading extra metadata and it's prepping your files a little bit. And on top of this, if you have been working in R already for some time, maybe even before today's session, you have started working in R, your memory is already piling up. R is weird in terms of memory management. And I'll explain you eventually how it works, right? But the most optimal solution is when you start with a new project is to clean up all the memory. So one way in which you could think this will happen is to clear the workspace. Yes, remove everything and run the garbage collection again, GC, but you'll actually see your memory, hasn't changed. It's still occupying this memory. Well, maybe a little less here, but it's still, it's still full. And that has to do with the fact that R can't properly delete the memory. Well, it can free up memory, but it will only when you create new objects, it will first use the memory that you have deleted. But you're never going to be able to decrease your footprint. So suppose you're using 412 megabyte of memory right now, and you're deleting stuff, you still have your computer blocked with 500 or 500 megabytes of memory. And on an 8 gigabyte machine that runs on Windows, that can already be a lot. Now, how to properly wipe this is to clear the workspace and to restart R. And if you now run the garbage collection, you actually see that you're only using 64 megabyte of memory, right? It's not a big issue for what we're doing today, although this one computer with 8 gigabyte of memory already has some problems. So maybe you need to shut down some gaming engines and, you know, close Netflix and close your web browser to free up some memory elsewhere. That's an option, but you know, I am always hitting limits with memory management. So that's kind of my trick to survive this. Another important trick to load data, you know, let me load it again. Take some time. But are they still, can everybody load the data except Wouter? Oh, you're still not, you see my screen now, right? Because I'm late to the chat. Yes, okay, good. If you run the nrows command on this new nrow on this new data frame, you see it has 400,000 rows. That may be too much for some. So when you write question mark read CSV, you get a little help file on this. And if you were to study this closely, you'll find an n_max comments argument and max read CSV. And if we scroll down to the explanation of what that means, and maximum number of records to read. So something that you could do too is you could add a comma and then write n max is 1000, for example. So if I rerun this again, it only reads an n row of read CSV, n row of D is 1000 lines. In this way, you can limit the file sizes of what gets loaded. I'm working with a colleague on a project with retail scanner data. So it's like people going to the supermarket and then scanning kind of what they buy. We have that data for like 10,000 customers or maybe 20,000 customers. And my colleague working in this department, he's unable to load this into memory. So what we do always when he works locally on his own computer is that he restricts the file sizes. He just loads in data for fewer observations. And the good thing is, guys, because you write code, if you have access to a larger computer, you just remove this little thing down here, like to remove the limit, and your code still runs. So that's maybe one of the lessons here in workflow management, in the sense, you know, we can develop stuff on small things and later on scale it to everything. You know, if estimating a regression model in your thesis takes 5 minutes, you know, that's not efficient. Scale down, take a sample of the data set, develop everything. You know, significance of variables is likely not changing when you increase the sample later on. Work with a sample, and when you take a break, just remove this little n-rows condition, remove the sampling and run your code. And when you come back from like running or whatever you do in your free time, you have the results of your analysis, right? So rather than seeing this as a limitation, it's actually a thing that makes you more productive. By the way, good Wouter that you're back to live on your computer, but it's going to crash a lot. 8 gigabyte, like my phone has more memory, I think, than your computer. So, you know, I'm not sure you'll, you know, everything will work, but we'll see about it. So we get the data set. Anybody can tell me something about the data? What is in the data? How do we do this? How do we explore this data set? Have you explored it already? Give me a story about the data. What's there? So, yay, good job. So let's do summary, right? The summary of D gives us a descriptive statistics about variables, right? So, I mean, a very good way to get to know what this data is about is also just go to this website inside Airbnb, get the data, and kind of understand that data, right? So the review CSV was dumped on 6th of August, so it's relatively recent. Detailed review data for listings in Amsterdam. And now we can start exploring this data a little bit, right? So for example, we can compute the length of the number of unique items of listing IDs. So how many properties is this data set on? By the way, listing ID, length, unique listing ID, that can't be true, right? Because is it true that we only have, maybe I'm still working on the sample. Yeah, I'm still working on the sample data set, obviously. So let me just load this thing again. And then I get the full picture. I don't know. Anybody knows the answer? How many do we have in the full data set? How many listings? How many properties? Yeah, all right. Length of the unique. And what if you do length, not of the unique? If you just do length, try it out while I'm typing the rest. Exactly. So this is the number of properties. And if we do this, what does it give? What's the answer? Let me just do it like this. I'm writing it up here. Editing is much faster. That's exactly the length of the data set. The length of this data set is 400,000 rows. So the length of this data vector is also 400,000. Same thing right here. All right, what are other things that I want to know about this data set? You could also just like write D and press enter. Let's see, I'm typing up here. And we can like look at it a little bit. An alternative is to write view D. And R opens up with a little, more fancy looking thing. So you can explore the data a bit. You can go right and okay, so you got comments, and your review name, and review ID. All right, that's interesting to do. An alternative way to get to the same view is to click on this data. And it opens up. What do I want to know about this data? Let me continue. D. What is it? We can do computations on this data. So for example, when do reviews start? One way to do this is look at D date. And we get the minimum and the maximum. But another way to do the same thing would just be to directly compute the minimum and the maximum, which you can do like this, right? Min, max. Where the hell do I know all of these commands? Well, it's a year-long practice and cheat sheets. So this is the wrong class. So again, I point to cheat sheets, and right now zoom in a little closer to what I want. Base R, let me see. Oh, page not found. Oh, I need to update data transformation, base R cheat sheets. And these are all too advanced. So let me find you guys a better one. Yeah, this looks cool. So let me post this. And since you're interested in GitHub anyways, I'll quickly make an excursion to GitHub and update the course site immediately. So it goes course dPrep. Remember, the stuff was listed in the building block section, cheat sheets, index. No, oh, by the way, Wouter, you don't need to memorize anything. I mean, it's an open book exam, and I have cheat sheets all the time. See, like coding wouldn't work if we weren't able to like look at the work of others. And you're not allowed to like ask other students in this class what they would write in the exam. But hey, it's of course possible to use cheat sheets and stuff. So right now, base R, I'll just replace this with a better version and update, fix links. So like in a few seconds, that site is also up to date. That's why I love GitHub, and that's why you learn GitHub, right? So what you see here is this indexing, what I've told you, writing loops, lists, types. I mean, yeah, got pretty much stuff on there. If you find other ones here, math functions, sum, mean, median, quantile, rank, variance, standard deviation. So yeah, it's essentially all there. So print it out maybe, yeah, work with it. So let me see what other stuff is in the tutorial. Sorry for switching screens so much, but let me see. What do I want to go through? It's not the one. We are in starting with data. So I have covered looking at the data, importing the data. Inspecting data frames, and row and call. Oh yeah, another useful command is head, for example, to look at the first lines, or tail to look at the last lines of a file. It's all there. Yeah, just try. Oh, what's that? Glimpse. That's interesting. Glimpse. I don't know. Oh, it doesn't work. Glimpse. Oh. Not so important, I guess. You can play around, for example, looking at the first 10 lines of the data set, 1 to 10, or looking at the first 3 columns. You get the first 10 lines and the first 3 columns. If you don't enter an argument before and just look at 1 to 3, it's gonna, just give you a preview of the first 3 columns. Is it a good practice to refer to columns like this? Hell no, it is not, because the raw data may change when you load it again, and suddenly columns change and switch. So it's not a reliable way to refer to columns. So it's way better if you want to look at particular columns. For example, you want to look at ID and date. It's a vector of column names. So I'm scrolling through this to see what are other stuff I can do. So for example, if we want to work through these exercises now, let's just do that. Create a table, call this interviews 100. We can call it Airbnb 100, containing only the data in row 100 of our Airbnb data set. How would we do that? Put it in the chat. Okay, this we have. Oh, that's a good one. So try to work on number 1, and then also try to work on number 3. Containing only the data in row 100. Who got the solution? Put it in the chat. You'll win eternal fame. Yeah, you're getting there. That's true too. But I showed you a quicker way. We can figure out that filter command in a bit, Umber. But indexing is fine, right? These are our data set. If we want to look at row 100, we can just do row number and all the columns. That's why comma nothing. And you get that row, right? It's actually damn easy. We'll cover this filter command in just a bit. Anybody has an answer to question number 3? The row that's in the middle of the data set. How can we do that? How can we determine which row is in the middle without looking at the solution? Maybe it's too obvious because you got the solutions, right? Oh, median. Yeah, that's a smart one. No, it was median. Yeah, we need to compute what's the middle, right? So the way I would have done this is look at the n row of D, which is this, and divide it by 2, which is a row, right? Or we can just look at D of this. That's how I would have solved it. Ooh, and I need to say that I want to select all of the columns, comma. That is the middle row. Now, just imagine this data set was one row smaller than what I say. And row D is this. So we'll take a copy of this and let it run from line 1 to all of the rows minus 1. So I'm actually cutting this short by 1 row, the minus 1, which is 400,325. If I'm now trying to run this n row thing divided by 2, it's not like a row number, right? Because rows need to have like proper integers. They can't like be rounded off. I'll answer that in a bit, Bram. So we would have to round it down using the floor command to round it down to the nearest integer, or the ceiling function to round it up to the nearest integer, or using the round function with 0 decimals to round it to whatever is closest to the number. How do I know this? Well, question mark round gives me all of the stuff: ceiling, floor, and truncation and rounding. And when we look at round, you need to specify the number of digits. Okay. Why am I sometimes adding an extra comma? Okay, I'm doing data selection. A very good question, Brown, by the way. So let's look at the dimensions of this data set. Dimension means how many rows and columns does this have? Okay, so this has 2 dimensions. The first dimension is 400,000 rows, and the second dimension is 6 columns. But you can imagine objects of different sizes. Objects can be multidimensional. They can be 10-dimensional, right? So with dim, you get like, what are the dimensions? All right, suppose I wanted to select stuff from here. I need to specify which dimensions to do. Okay, from the first dimension, I want the first 5 rows. From the second dimension, comma, I'm pressing comma. From the second dimension, I want the second column. And then I get this. When I don't add a comma, it doesn't know, like, what do you want, right? Like, from which dimension you want to have stuff? Well, I don't know. This is a 2. Oh, this works, by the way, but it shouldn't. Yeah, I mean, okay, maybe I'm invalidating myself, right? Usually what you do is you specify all the dimensions. And when you don't want to do anything with a particular dimension, you just leave it empty. That's maybe my best exclamation. Why do you sometimes add an extra comma to the end? Yeah, maybe it is because rows you can always select like this. But yeah, I mean, if I was going to do this, like if I'm playing around, maybe that's why I'm adding a comma, because otherwise I wouldn't be able to select columns. Maybe that's my best answer. And when do you use bracket and when do you use square brackets? Square brackets are entirely reserved to subsetting stuff. If you want to select stuff, like the first few observations, it's with square brackets. For all the other things, you're going to use the regular brackets. I'm looking at Noah's question.
Could you repeat that?
What's that?
Could you repeat that, what you said about the brackets?
Yeah, what I'm saying is R knows normal brackets and square brackets. All right. You always use regular brackets, except if you want to select stuff. So for example, if you have a vector from 1 to 10 and you want to select the fourth number, this is how you select. The square brackets select. Okay. A few other things. Yeah, the middle. See, so Noah has a good question. So when you have an uneven number, right? So n row of what was this? D minus 1. That's how I called it. Is this? So this is an uneven number. And I'm doing like this. You're saying you should use the floor function. Well, floor, there are multiple. So this is not a row number, right? You agree with this? If you divide the total number of rows by 2, it's not a number. And there are multiple ways in which you can get to an integer. You can round down, you can round up, or you can round whatever is the most appropriate way of rounding. That's why you can use, anything here. Trang, what's the difference between, for example, new variable is Hannes and new variable is equals Hannes? For you guys, there's no difference. Does the same thing, works. There is a little difference, but it really just occurs in advanced operations. Like it has to do with like local variables and global variables. Like if you're writing a function, variables that you define inside that function are only available to that function, unless you use 2 arrows. And this is something you can like quickly forget because it's like super irrelevant right now. But in this case, we should use 20,167. And yeah, I mean, it's just a mock-up question. And these people, they're using it, they're solving it also differently with like, I don't know, the median of the row numbers or something like that, which is also great. It's a different way of getting to the same answer. Let's not like get stuck up on this so much. This is an interesting data type. It's called factors. So when we look at our data, we can look at the class of oh, actually, it's already up there. I think it's character. Okay, let me try to think about this a little differently. Storing characters is expensive because the memory that each character takes, is expensive, right? We need to store an L, an A, an M. We need to store an A, an L, an I, a C, an E, all right? I work with a data set of, I don't know, 400,000 rows. And I have a column called label name, music label name. So it's like songs that are released on Spotify, and I record on which label it got released, like Universal, Sony, Warner, or any other thing, right? But there are way more songs than there are labels. And mostly my data set looks like this: Sony, 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 Universal, 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 other, Universal, Universal, Sony, Sony, Sony. So if I was going to store this with characters, I'm storing all of these characters, but I'm repeating myself, right? Sony, 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 Sony. So the way R handles this is by defining a factor variable. Okay, I'm defining a factor. So new variable is as factor Sony, 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 Universal, Universal, other. This variable actually only looks as if it is storing the label names all the time. As a matter of fact, the only thing it stores is the levels, so all of the values that I have uniquely entered, and the mapping of the label name to these levels. So actually, it's an incognito numeric variable. All it stores are numbers and the names of the numbers. So there you go. If you encounter such a variable type, and you load it as a character, sometimes it's more memory efficient to convert it to a factor. I don't expect you to experience a lot of problems, but if you observe R doing weird stuff with like variables that have characters, it could be that it treats it differently because it's a factor. So I think this is all what you need to remember. Another cool thing about these things is that lots of stuff is pre-computed. So if you look at the frequency distribution by doing table, this is like very fastly computed because all it needs to do is counting numbers and not counting letters. It's way more memory efficient. Think about having a data set which is really big. And you could also relabel these things. So if you take the levels of mule var and you want to, these are the labels, and I'm selecting the first label, and now I'm adding a new name to this label. It automatically gets renamed for all of those. See? So it's a way better way to handle this type of data. We can also convert them back into like, characters and numerics and, all of that stuff works very well. So that's here. We can rename the factors, which I have just done. And yeah, we can do some plotting, I guess. Does this work? Plot mu var. Yeah, exactly. And you get like a little plot here that you can readily use. By the way, something that I really love to do when I plot is to look at galleries. R plot gallery bar chart to know how I can style up my my graphs. R graph gallery. Let me see. Oh, this looks cool. I think. Let me see. Yeah, this is the stuff with ggplot, and we're not here with ggplot, but it's like a good bar plot. I mean, it's a good stuff to do, and you'll learn quickly how to do by imitating the work of others. You remember me telling you about like why learning to program is like learning to skateboard. At least that's how I can relate to this. Is like, yeah, I mean, you just observe the others in your environment and about how they do things, and you just like bluntly copy the behavior. If you fall down, try to correct your mistake the next time you do it, but you keep on imitating and imitating and imitating. And something in the evolvement of higher education got wrong in the sense that we instilled the thought that looking at others is bad. Obviously plagiarism is not the way to go here, but imitating others and learning from others is something we need to stimulate more. And that's exactly what you do here in programming. Good. I don't know how you are doing, but I'm running a bit out of steam here. So let me see what other stuff I want to cover today. We got, yeah, I mean, you could just walk through this a bit. I mean, you can do calculations with dates, right? We got dates here. Let me check that out. D, it has already recognized this is a date format. And I think you can add new data to this table, saying D year is year of the dates, year, sorry for that, is year D date. I could not find function yet, so I think we have to import this lubri date function. And we can add like a data enrichment to our data set. Well, you may wonder, like, there you go. So if we look at it now, we have view of D. We have an additional year here. You may wonder, like, that's like super boring. Why are we doing this? Well, sometimes in an econometric model, you want to add fixed effects, like dummy variables for a year. Like you want to control for the year in which something happened. And then you need a quick, fast way to create that variable. Well, here you go. You've just extracted the date. Or you may be interested in making trend variables. For example, the month, maybe such a thing, right? And then you can control for the month number. So if you have sales patterns and they spike always at Christmas, the month number will control for this. Or you can create a Christmas dummy by saying dChristmas. If the month is 12, then Christmas is true. Otherwise, Christmas is false. Okay, how many Christmases in this data set? Ooh, table D wasn't the case to go. dChristmas. Okay, so 22,000 months and reviews that were written around Christmas time. Let's say if Christmas was like just in this month, right? So like, you know, you can flexibly enhance your data. And that is what you do in data preparation and workflow management. Actually, there's no single instance that I can remember where you just take a data set and go about this data set and analyze this data set. You'll always have to enrich the data, right? You need to add more data. You need to merge it with other stuff. You need to create dummy variables. You know, there's a whole stuff going on. And that is actually part also of a later tutorial where we zoom in more on these kind of settings. Which brings us to the last two chapters. And probably I'm just going to give a little glimpse and then leave the room a bit open for you to ask questions. A comment about dplyr and tidier. So like I said, these packages are developed by RStudio, but they are certainly not the only packages to wrangle with data, to prepare data. In fact, I find them not so efficient with large data sets. And for my work, I use a different package. It's called data table. And I'm posting this to the chat, which I believe is way more efficient when you work with really huge data. If you look at the Airbnb code snippet, which I shared earlier, and I'm putting it back into the chat, try to load the Airbnb data with the first function versus try to load the data with the second function. Watch this. Remember how long it took? Let's watch. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, after 9 seconds. Now watch my friend's data table. 1, 2, 3, 4. Shit, it doesn't win. 6, 7, 8, 9. Is it even slower? Well, you need to trust me. For real data sets, if they're already downloaded to your disk, it just takes the amount of time it took this bar to populate. It's lightning fast. But the syntax, so the way you write comments is different for data table compared to dplyr. So they're trying to make them more compatible, but they're not. So why am I teaching dplyr and tidier then, or at least why do I recommend doing this? The thing is, most of the tutorials on the web that you find today are in dplyr and tidier. And because it's a tidy way to write comments, like it looks good and you actually understand what's going on here, better than with data table, it's the preferred package for many students. But you know, there is no one size fits all solution, and you need to stay flexible to determine, like, you know, what suits your needs, and just be open to, you know, trying out new stuff. It does similar things than what I've shown to you before, but you know, it does it in a different way. You know, for example, filter D, and we want to select the dates. Ooh. How does it work? Oh no, this is cases selection, D. Okay, we want to extract, actually that's a good one. We want to extract all the reviews that Lamb has written. We could do D, filter D, and we could say reviewer name equals Lamb. Okay, here you see I'm really not good at this. Filter, or maybe I first need to load tidyverse. There you go. Yes. So now we can run this command. Filter D gives me 5 reviews that Lamb has written. So it's like a very flexible way. If I don't want to do it in dplyr, I could also just say D reviewer name equals Lamb, like this. And we need to select the columns. And you already see this command gives me the same result. It doesn't rely on dplyr, but this filter command is, you know, nicer, because even somebody who doesn't know R somewhat gets that somebody is filtering something here. Oh, and probably it has to do with a reviewer called Lamb, whatever, right? And like this, dplyr offers you many, many ways in which to fiddle around with data and specify multiple conditions. For example, filter D, where for all reviews that have been written between 2020, 1st of Jan, and where date is smaller than 2020, 12/31, last. And you get 31,000 reviews that were written in that particular year. Obviously, an alternative would have been, because we created this variable, to just filter for the year 2000. Why is it again that this doesn't work? Call names D, we have year, right? Oh no, I deleted year. D year equals year D date. Now I can filter for it. There we go. So I suggest you actually that, probably the best way to work through this is just take this data, because it's more exciting than, the data that this tutorial runs in, and try it out on how to do this. I would also point out to you that later in this course, when we engineer data sets, there's also going to be more on tidyverse. And maybe I can even enhance this tutorial still a bit now that I know you're already up to speed a bit with tidyverse. So yeah, it's something that's extremely useful. Maybe I show you a little bit about where you're going with this ultimately. When I open up one of my research projects. Give me a second. Why do you want to learn all this, right? How can I keep you motivated for this? And I'll explain you how, because this is the kind of complexity we're looking at. This is for this project where I'm working on the last few revisions before it gets published. These are the number of folders for data sets that we're using. I don't know, maybe this is 21 directories. In each of those directories, you have multiple delivery batches of files that we got. Here we got data from New Zealand. Here we got data from Hong Kong, China, Australia. I mean, we have multiple, it's just full with data. And in my code folder, these are the amount of R files that I've written to select and crunch and prepare this data set, right? All with data table language or dplyr language, depending on whatever task happens. I'm turning 4.3 gigabyte of data, which is not a lot, into one final output file called datasets main of 600 megabytes, where I merge and mingle all of the things. And this is going to be the data set that I analyze. I'm going to give you another example, which is the platform power project that I work on with my colleague, Max Pachali. Let's look at the raw data files. The raw data files are 50 gigabyte. It's also not that much, but still, a lot more than it was. During the process of wrangling this data, I produced temporary files. Actually, that can't be true. I need to go on a different computer because this is an older version of the project. Again, 50 gigabyte of raw input data. Oh, it's correct, actually. 4.3 gigabyte of temporary data. And actually, from this, I'm creating 82 gigabyte of final output data. I'm creating even more than I have at the beginning because it's enriched and maybe blown up, all kinds of things. And this is the data set that I ultimately will analyze in this project. Well, actually, multiple data sets come out of this thing. So why are you learning this? And why am I showing you this? It looks very simplistic. You have this one data set and you need to filter around. But what you're having to consider is that you're building a complex project consisting of multiple files. It will take a long time to run. And it's very important that you have your skills well in place on how to wrangle with this data. And this is what R can offer to you. Let me see on final comments here, but I think I'll leave 5 more minutes to taking questions. Yeah, and then there's plotting, which if you have a question, you can go through. But I think it's really something you need to experience. And I would suggest you do it with the Airbnb data because it's fun. Good. Any questions up to this moment? You also need to tell me how you like this session in a way, because I can still adjust. Like students last year, they wanted like me to talk them through like this, but maybe you're different. I don't know. Is it boring for the people who have already gone through this themselves, or do you think it's complementary? Give me a go or no go. I don't know. I'm curious to hear your thoughts. Maybe this is what I referred to in my opening lecture as brain dead by coding. But yeah, thanks. Good, thanks for the comments. Okay, thanks that you see some added value here, that's good. I'm trying to do that. Where possible, good. Yeah, Wouter, I understand it's overwhelming. What do you think is overwhelming? Is it just the many new things that you encounter? No. I'm just reading. Yeah, it's a lot to take in. Yep, I understand. But yeah, just like, don't be stressed out about seeing things that you don't see yet, right? So sometimes, right, it can be so overwhelming, but then just pick out this one little thing that you want to learn. And once you've learned this, you know, the other things open up to you. So, you know, follow this step by step. So if you haven't followed this tutorial yet, my recommendation would be, you know, maybe just, you know, work on a chapter, take a break, and work in another chapter, take a break, wait for the next day, work through something else, right? Do it step by step, because even if you don't do anything, you'll kind of, your brain does some magic and you'll learn some stuff and you understand the context better. Good. I'm done in a way. So are there any other things? Otherwise, I just give you a brief preview of what's there to come next week, because next week is going to be really amazing. So the thing is, I showed to you today how to get started in R. So R is our workbench to getting stuff with data done, whether prepping stuff or analyzing new stuff. Next week, you get introduced to the magic of GitHub. That's like versioning files, unlimited rollback possibilities, and managing your project in a professional way. And after finishing this project, you're actually able to change the course website with anything you want to be put on. And you will be able to change any content on tilburgsciencehub.com, our platform that you may have been familiar with. So, you know, maybe you can spot some mistakes, or, you know, think about something that you want to rewrite to make it better, something that you want to add, because at the end of this tutorial, that's exactly what you can do. So another thing why this is extremely cool is, you know, look at this webpage by my colleague who has helped me build this class, but also, for example, Lachlan Deer, when I search for him, he's my colleague. You know, you go through his page and, you know, it gives a little nice profile view of what he has, and he has a blog, and he has packages. You know, this is everything you can do on GitHub and launch websites like this. So when you go on the job market to get a job, you know, have your paper CV, but, you know, if you go in data science or marketing analytics, people are going to check you out online. So make sure to build your profile. So also with these skills, you will be able to do this. People, in fact, use their GitHub profile to look for jobs. All they do is send this to a company, and people go through this portfolio of stuff that they've done. Your portfolio will be analytics projects that you'll pin to this repository, but, you know, and maybe the website and changes you've done. And you can show off that you're active in a coding community, because that's what people are looking for when they look for analysts. So that's it. There is a question. My Mac becomes really hot while running R and Zoom together. Sorry, even though all the other applications are closed. I have a Mac and I can't follow it. So Mac is not a problem. It's just probably the age of your Mac. So yeah, nothing here to do. Maybe you can figure out a way to, yeah, it's an old Mac. Something that you can do is maybe look for ways to run R in the cloud. So you don't, you only have to open your browser maybe. But I'm not familiar with tools right now. Maybe, well, actually you can run R in Google Colab. So here's a post, I actually looked this up during the break. So I'll post that to the stuff, but to the chat. So check that out. Yeah, but your equipment is very dated. So for analytics, it's you'll hit some boundaries on that laptop, I think. Okay, good. But you still have the cloud. I'm closing the recording for now, so thanks for being here. And then I take questions you don't want to post in public.